Hello everyone. In this lecture, I am going to discuss an important concept, how to check the functional completeness of any Boolean function. The meaning is, let's say any Boolean function is given. Any Boolean function, let's say you consider a, b bar or a bar b. This is the equation or Boolean function of XOR gate. Now let's say if I ask check whether this function is fully functional or not. What is the meaning of this statement? A function will be fully functional in case that function is capable enough to generate three fundamental operations. So the three basic operations are in Boolean algebra is negation, the complement, or AND operation. So if any of the function, any given function can generate these three operations in any of the manner, then we can say that function is functionally complete. Okay, but let's say in case a function is only able to generate negation or complement, or let's say plus. So you know that if a function is able to generate negation or complement and OR operation, then by applying negation on OR we can get dot or AND operation by applying De Morgan's, right? Similarly, if a function is able to generate negation means complement, and dot, then also if these two operations a function is supporting, then we can generate by applying De Morgan's, we can generate OR operation. So a function will be considered as fully functionally complete in case either all these three operations the function can generate, or along with complement, either OR operation or AND operation the function can generate. Okay, so let's say this XOR I will take later to verify whether it is fully functional. Let's take comparatively easy example. So let's say if you are having a function here, let's say we are having a function which is defined over three Boolean variable, let's say a, b, and c, and the function is, let's say, a complement b, c complement. Now if you want to check whether this function is fully functional or not, if let's try whether we can generate a complement out of this function. So let's say if I pass all the inputs are same, in case we pass f a comma a comma a, let's see what it will generate. So it is generating a bar or a dot a bar. So this a bar or it will generate 0 here. So a bar or 0 will give us a bar. That means in this function, when we pass all the inputs as equal, then this function will generate the bar of that particular input. Similarly, like in NAND is also fully functional, we can say. In NAND, when we pass same input to both the terminals or all the terminals like A, NAND start generating a bar. Similarly, this function which is having three input a, b and c, if we pass all the input as a or b or c same, it will generate the bar of it. Okay, right? Now the next thing is, this is supporting complement. Now we also need to validate that whether this function can generate either AND or operation. So how we can generate AND or operation in this, we need to think for some of the values which we can pass here. So in case you assume that, let's say I'm changing the pen color, here it is generating a bar. So if I am intended, let's say the function f, and I am passing some value here, there are three inputs, and I am actually intended to get a plus b. I'm interested to generate either the AND operation or operation by applying this function. So how we can get a and b if this is the function a bar plus b c bar? If instead of a, if I pass a bar, because a bar I have already constructed out of this function, so wherever I need the complement operation, I know how I can get complement, right? So if I pass here a bar, this will become a bar of bar, so it will give me a. Now here, instead of b, let's say I'm passing b as b, so b is b only, but instead of this c bar, if I pass here, let's say b bar, right? So because we are having a b c 3 input, instead of c, if I pass b bar, this will become b bar to the power bar. That means it will become b, and it will become b dot b. B dot b will give us b only, right? So if we pass these three inputs a bar, b, b bar, this function will generate OR. So that means this function is able to generate or support these two operations. It can generate complement bar, and it can also generate OR operation like this. That means we can say this given function is fully functionally complete. That means this function can be used as a universal function. Like we consider NAND gate and NOR gate are universal gate, because NAND and NOR are functionally complete. They can generate negation, they can generate OR operation, and they can also generate AND operation. That's why both are universal gates. Similarly, we are checking here the functional completeness of functions, right? So let's say if we get another example to check whether a function is fully functionally complete or not. So let's say we are having a function f over a and b. Now let's say this function is given as a bar b, right? So if this function is given like a bar b, first what we try to do is we try to find out the complement. Okay, so let's try to find out the complement out of it. In case you pass both the inputs as a, sorry, so what we will get here, a bar or a, it will give us 1, but this is not the complement, right? So how we can get the complement? There is only one way, which is clearly visible here. If we pass a comma, here if we can pass 0, Then, so let's say to this function, if I pass a and second input I am setting 0, this will give me a bar plus 0, and a bar plus 0 will give me a bar, right? So this function is requiring one input as 0, right? That means one, if a chip is there, function means a circuit is given which is having, let's say, two input and one output. One pin you are fixing, it will get 0, then only it will generate complement. Okay, so in case to generate complement or operation or AND operation, to check a functional completeness of a function, we need to pass either 0 or 1. Then we can say such kind of functions are partially functionally complete, partially functionally complete, right? So because we need to pass this, now if you want to generate or operation out of it, this is very easy. So in a function we can pass a bar, because bar we have already generated, and we are setting b here. In that case, it will give us a bar to the power bar plus b. So it will give us a b. That means this function is capable to generate complement as well as plus. So that means it is functionally complete, but in order to generate complement, we need to pass 0 here. That means it is partially functionally complete. Okay. So this is partially functionally complete, and the previous function was fully functionally complete, right? In order to get the complement, we need not to pass any of the input either as 0 or 1, right? So with this, I'm ending this lecture. Thank you.